All right, so today I have my friend Hagay Lupesko back. He is Senior Director of Engineering at Databricks MosaicAI. So welcome back to the Data Exchange podcast, Hagay.
Hey Ben, thanks for having me again. Awesome to be here with you.
So for people who are not aware, Mosaic was a leading startup that was acquired by the mothership, Databricks. And as listeners know, I'm an advisor to Databricks. And Mosaic Research recently published a new open LLM called DBRX. And I'll put a link to the announcement post, which has some details. But in this podcast, Guy and I will talk exclusively about DBRX, and I have collected some questions from the people. So this is not going to be just an kind of a friendly conversation. We'll try to press a guy on a few items here. So first off, a guy, what inspired the development of DBRX, and what gaps does it aim to fill in the current landscape of LLMs? And as many listeners know, there are already quite a bit of LLMs, many of which are open.
Yeah, so we build DBRX to enable our customers, enterprises, to as well as the ML community, to build general applications and push the field forward. There are definitely, growing number of LLMs, some closed, some open. We try to build one that would be a good trade-off between quality and cost of serving, and would also work well for key applications that we're seeing customers building, which is mostly RAG type of applications. So we try to build DBRX to really fit kind of that need.
And so you said it's meant to enable and empower your enterprise customers, of which Databricks has many.
Yeah.
So what was missing from the suite of options? So set aside the proprietary LLMs, but weren't there already existing open LLMs?
Yeah, there definitely are. And, just to call out really awesome companies in the field, that Mistral is definitely one who's been doing fantastic job with their open models, including Mistral. And there's definitely others. We did see a need to kind of bridge the gap between open models and closed models, because that gap still exists. And DBRX is an attempt to basically offer a really state-of-the-art open model. And closed models exist and they're very useful and they're used by many companies, but open models enable things that you can just not do with closed models. Like, you can fine-tune them and then own the fine-tuned models. You have more control over how you serve it. So you can serve it in your own secure environment and don't have to send the data to another provider, which for some customers we have, by the way, it's a blocker. They can just not use these providers because they can't send their data out of their premise. And the other thing is also, just contributing to the open community, the AI community that all of us are benefiting from, allowing the community to experiment more, allowing academia to have some kind of a baseline. And it's good for the community. It's also good for us, because when academia or the community or the companies are, for example, optimizing the models or finding a way to improve it, they contribute it back and we can also leverage it. So, we see it as sort of a win-win.
So, as many listeners have heard me say, right? So, while we think that there's actually a lot of open LLMs, the number of providers is quite limited, right? So you mentioned Mistral, but the reality is in their last release, Mistral Large is no longer open. There's Meta. There's other open LLMs, but frankly, they're not competitive. So as you mentioned, Haggai, so there is still a need for a provider that's committed to remaining open and committed to updating an LLM, right?
Exactly. Yes. I think Mistral is an example where, it's like any commercial entity, right? They are open sourcing some of their work, but then they also need to take care of their, business interests. So some of their newer models like Mistral Medium, Mistral Large is actually closed. So yeah, I think the community and companies can definitely benefit from more high quality open models.
So we'll go back to this notion of open model later, but right now let's go into some of the technical innovations and architectural innovations for DBRX. So one of the things that caught my eye is mixture of experts, which
Yeah.
is not unique to DBRX, to be fair, right? So other LLM providers are starting to gravitate this way. So can you explain to our audience how what your folks' unique twist is to mixture of experts, and how early in the design of DBRX did you folks decide to go this route?
Yeah, so this was fantastic work by our research team who was looking into it very early on. And we tried to be very thoughtful about the model we would offer. And like I mentioned earlier, there's sort of a trade-off between the complexity of the model and the cost of serving. And, you know, for practical purposes, you tend to want to, limit the cost of serving as much as possible. But then if you want a high quality model, you need to notch up both the model size and the amount of training data. And again, the model size directly impacts the cost of serving. So pretty early on, our research team did a lot of experiments comparing dense model to sparse model or mixture of expert model, and trying to figure out what is exactly the benefit we'll get out of MOE, how much do we lose, what do we gain, and the results were pretty promising from early on. So with mixture of experts, just for the audience who may not be aware, it's actually the idea was proposed by Google earlier on. There is a paper that actually does a pretty good job explaining the mixture of expert concept. It's a bit different than more of the traditional ML MOE that just uses different models. In transformer-based mixture of experts, every transformer block has a router that chooses which expert to route the token to, and typically chooses, k experts out of a total of n available. And the same thing is replicated across the different transformer blocks. So it's sort of within the transformer architecture. It's not, an external set of experts that are run. One key advantage of MOE is that you reduce the number of computation you need to do in a given forward pass for every token. While at the same time, you still maintain kind of larger number of overall parameters. So in theory, the model has more capacity to learn because it has larger number of parameters, but then at every forward pass, not all parameters are activated, which reduces the computational cost. We found that this is a good trade-off in the sense that it does allow the model to learn more, although not the same, right, as a dense model that uses all of these number of parameters. But then training becomes much faster, like 2 to 3x faster compared to dense model of the same quality. And the same benefit is also achieved on inference time because, again, not all parameters are activated. So we found it to be a really good trade-off. There are a lot of details, of course, like, the choice of hyperparameters of the architecture, like the top K. So how many experts are you activating in each forward pass, in each one of the blocks, as well as the total number of experts. If you look at what we can see in Mixtral as an example, as well as Grok 1, they, I believe, use the top K of 2, using 2 experts over 8 available experts. We actually experimented with different options and went with something a bit more expensive. So we have a top K of 4 out of 16. So we choose 4 experts out of a total of 16 available. We find this to yield better results in terms of the quality of the model. And one way to think about it is the number of combinations. Choosing 4 out of 16 is like, I think 60 or 65 times larger than comparing to choosing 2 over 8. So one way to think of it is actually allows us to, the model to have more capacity of learning and more options to choose from, which yields better quality. Of course, there's also, cost in terms of the forward pass where, you have more experts and then you have more computation going on. But we experimented a lot with the different options. And yeah, so, I believe that mixture of experts, not just for us, but across the industry, is going to be something we'll see more and more of, just because of, that trade-off I mentioned earlier, where we want to get to higher quality of the model, but then we have to constrain the cost of serving, because otherwise it just becomes impractical. And there are, I think Jensen in the last GTC conference shared some details about OpenAI GPT-4, saying it's a mixture of expert model with total of 1.8 trillion parameters. So, we can also see some of the industry leaders have been using mixture of experts as well for a while. So it's probably a direction we'll see more companies follow.
And I believe Gemini is also a mixture of experts. I'm not
Yes.
sure if Claude has publicly mentioned anything along these lines. So in my mind, those are the top non-open models, right? So Gemini, by the way, Gemini 1.5 is quite good. I don't know if you've tried it. The API is quite simple as well, right? So
yeah, I think Google definitely seemed to have caught up on the gap, and I can tell I use these models daily, just as kind of an assistant to the work I do, and yeah, Gemini is becoming a really good model for sure.
So if you listen and read about Mistral, right? So one of the things that they emphasize is, we're a startup, like you said, right? So we don't have the infinite resources that some of these other companies have. So we have to be very mindful of making sure when we do pre-training new model, it's not super expensive. And one of the things that they take pride in, Hagay, is they do a lot of work as far as the quality of the data for pre-training, right? So, and I believe you folks did similar work with another Databricks acquisition, Lilac, right?
Yeah. Mm-hmm.
So can you explain? Tell us some of the other things that you guys had to do in order to really, be able to train a model without breaking the bank.
Yeah. So the data, it's kind of a well-known, right, widely known secret that the quantity and quality of the data both matter a lot for getting high quality models. We trained previously, before being acquired by Databricks, we actually trained MPT-7B and MPT-30B, and we kind of learned a lot of lessons. And we found that by curating the data better, we actually sort of get 2 to 3x more quality out of every token. So it's definitely an important investment. Now, we train DBRX. So first of all, quantity. We train DBRX on 12 trillion tokens. That's a lot of tokens. As a comparison, Llama 270B, which is a fairly good model, was trained on 2 trillion tokens. So we went 6x more on that, because we can see how it actually helps the model within the same size. Yeah.
6x of quality. In other words, 13 trillion, but if it's like quadruplicates of the same token.
Yeah. Well, I think Meta also took a lot of care of curating the data, and I think they did an amazing job, especially with their fine-tuning data. And if you read the Llama 2 technical report, half of the report is just about how they tune the model for safety and helpfulness. And I think it's that part of the technical report is like a master class. And I commend Meta for the incredible work on that. For us, the training data was mostly English, text, and coding data. And you can see, actually, if we get to talk about the metrics later on, I'll just say that DBRX is really good at coding. It's actually so good, it's better than Code Llama, which is a model that was fine-tuned specifically for coding. We also trained it on a maximum context length of 32K. And we chose this number, again, kind of coming back from the Databricks perspective of enterprise customers and their needs. We think 32K is a good balance between, what the actual customer actually needs for ag applications, while still keeping things, not too long. Because if you make it too long, then your training kind of defocuses a little bit. And there are other companies that offer 100K. I think Gemini publicized 1 million tokens.
Multimodal.
But that's we kind of wanted to hit the right trade-off to address the actual needs of businesses. So we think that's the a good trade-off to hit. We applied also curriculum learning, which we found a useful method, and I won't dive too much into the details, but DBRX is trained on open data sets from across the internet that the community uses and loves, and we curated those data sets to identify kind of the higher quality, higher complexity subset of the data. And we, throughout the training process, we started with more of the, simple and basic training data, and then gradually injected or started mixing more higher quality and more complex data, which we found to be really useful in actually pushing the model quality further. And then, of course, we also fine-tuned. That's part of our after training regime, fine-tuning the model. Now, DBRX, we open source 2 versions of DBRX. One is the base model, and then the other one is fine-tuned for instruction following. You can also use this model for multi-turn conversation and chat, but it's really fine-tuned for following an instruction and maybe having another turn. If you try to, it's not optimized for really long multi-turn conversations, and that's something we may release later on. So overall, kind of that's our training regime in terms of the data, and it's just as important, probably even more important than the actual model architecture and and all of that.
So as you keep alluding to, so Databricks is very mindful of its enterprise customers, and which might be different for some other parties that are training LLMs that might have more science fiction AGI aspirations, right? So what does that mean in terms of the practical details of training a model if you're more focused on enterprise as opposed to AGI? Does that mean, as you mentioned, right, so let's make sure this thing is really good at coding, so let's make sure we really have the best coding training set, and maybe worry less about other things. So walk us through in terms of some of the choices you folks had to make in terms of optimizing your training set.
Yeah, so one thing I mentioned earlier, which we think is really important for enterprise customers, is being a model that is relatively easy to fine-tune for specific downstream tasks, as well as deploy and serve in a cost-efficient manner. So for us, it's really limiting kind of the complexity with computational complexity, number of parameters, because it becomes really hard for many companies out there to serve a model that requires, let's say, 8 GPUs, like 8 top-end GPUs. So that is one concern, and I can talk about that a bit as well later on, but we are investing a lot in optimizing serving to reduce the cost as much as possible, increasing throughput and reducing latency. The other thing is we observe that many enterprises out there, as they try to leverage generative AI and LLMs in specific, they are building RAG applications. And I think, Ben, in your podcast, you've been talking a lot about RAG. I think it's not a secret that it's a really important design pattern for building LLM-based systems. And one of the important things in a RAG application is that the model is able to understand a long context really well. And if there are 30 fragments of input within the prompt, the model needs to kind of look at the question and identify the right fragment within the context, which may be long. So we focused a lot on these evaluation metrics. and it's also published on our the technical blog, a couple of metrics. We actually looked into the model's capability to find the right answer in different parts of the prompt. So we wanted to make sure that regardless of, whether the right information is in the beginning of the prompt, the middle of the prompt, or the end of the prompt, across all these 32K context lengths, the model is able to find it. And we're able to actually get to good results there. There's some comparison we did in the blog post, and the model is performing really well compared to all other open source models, as well as compared to ChatGPT. So that a lot of our focus has been on those, and we are actually always thinking about other RAG evaluations and RAG benchmarks, so we can make sure that the model is working really well for this use case.
So you talked about efficiency of deployment. So one of the questions from the people is exactly this, right? So are there any plans to develop smaller, more efficient versions of DBRX? Because I think Hagay people have noticed that the big version, the 132 billion parameter version, requires 264 gigabytes of RAM, Hagay. So it's not quite as efficient as you portray.
Yeah, well, if you serve it with BF16, so 16-bit per parameters, yes, you need 264. Actually, you need more, because for serving you also need the KV cache, which requires even more memory. But you can actually serve DBRX with quantization, so either int8 or FP8 if you're using H100s, the NVIDIA H100 accelerator. And with that, you can actually, you actually need 132 gigabytes of RAM plus some extra, change for the KV cache. So you can actually, with that, you can serve DBRX on two A100s or two H100s, which really cuts down cost. And that's what, by the way, we are doing internally. We're serving it quantized. There's also some nice work that happened in the community, which was exciting, where someone did 4-bit quantization of DBRX. It's actually available on Hugging Face. You can load it, and if you have a strong MacBook, you can actually run it on
4-bit.
a MacBook. I think 4-bit, yeah.
Yeah.
You actually can get something like 2 tokens per second, which is cool. The amount of compute, like GPUs, you need is one aspect. And again, we cut this down to 2 accelerators for serving the model. And the other aspect is also what kind of throughput are you getting out of it. And we are still doing and did a bunch of optimizations for launch, like QRT LLM support, so NVIDIA QRT LLM serving engine, VLLM support. VLLM is a super popular serving open source framework. We did operator fusion, quantization, and there's a bunch of other things that are in the oven at the moment. And we're able to get to more than 150 tokens per second. And I think many people that I talk to about kind of their impression of DBRX, they tend to kind of highlight how fast the model generates tokens, which is really cool to see. And it's thanks to all these optimization, but also thanks to the MOE architecture that allows less parameters to be activated on a given forward pass.
So one of the questions that arose in this area around efficiency and size of the model is that, as I pointed out, right? So the full version, unquantized, 264 gigabytes of RAM. But then you compare that to Mistral, 7 billion, or Mixtral. Yes, maybe in principle you outperform these models, but the incremental improvement is small compared to, you're making this ginormous leap in terms of size of the model and the cost of deploying it. So what says you, Hagay?
Yeah, it's a good point. First of all, I'd say Mixtral is a fantastic model. And again, kudos to the Mistral team on a great work building and open sourcing it. And by the way, we offer Mistral models on the Databricks platform, and they're very popular models. People love them, and I think again, it's fantastic work. The second thing I'd say is that it's important to know that the better the models get or bigger they get, the actual smaller incremental improvements become, if you look at kind of an absolute right basis. So, getting from 0 to 80 is one thing, but then the remaining 20% becomes more difficult. And, you'll see a big bump going from, let's say, 7 billion parameter model to 30 billion, but then going from 30 to 120 billion, right? Same 4x increase in the model size. You won't see the same leap in the model quality. The quality improvements will continue, but they will be smaller and smaller. So I think that's one thing.
So then why not just do a smaller model and work that to death, optimize the hell out of a smaller model? So what's the argument? What's the argument for?
Yeah, I think for some applications, it definitely makes sense to use a smaller model. And you can use Mistral 7B, you can use NPT 7B or other models. And actually, if you fine-tune these smaller models for specific tasks, in our experience, you're going to see pretty good results. And I think that's a great path for something. There are other applications where that quality bar just doesn't cut it. Quite a few applications, actually. And that's why we're seeing many people moving to a model like GPT-4, while it's much more expensive to use significantly compared to other models. Just the quality it delivers enables applications that for some things you can't use the smaller model. So this is the reason. I do think that the trend of kind of smaller models will continue because, like you said, right, it's cheaper to train, cheaper to fine tune, cheaper to serve, and and I'm hoping as a community we find more ways to make these models smarter and better. Maybe with things like distillation, which where the community, I think in the industry we're not leveraging as much as maybe we could. But as more and more Gen AI applications would be deployed, this pressure would kind of build up, right? Where companies would do a lot of work to figure out how to push the cost down. And reducing the number of parameters is one of these things that would push the cost down. The last thing I'd say, just going back to the comparison with Mixtral, again, Mixtral is a great model, but DBRX is significantly better than Mixtral on a couple of things. On coding, like if you look at the human eval benchmark, which is a coding benchmark, DBRX Instruct has about 70.1% accuracy compared to Mixtral Extract that has 54.8%. So that's a pretty significant difference. DBRX is really good at coding, by the way. Like I mentioned earlier, it's actually has better results than even Code Llama, which is a very large model, 70 billion parameters fine-tuned for coding. The other thing is on math or math problems. There's a benchmark called GSM-8K, grade school math. It's a math evaluation. DBRX scores 66.9%, Mixtral has 61.1%. So that's a big difference. It's true that on some of the other metrics, the difference may not be as large. And I think that's a lot of it is also how we curated the training data versus how Mistral curated the training data for Mixtral. So, these things would continue to matter. By the way, just a funny thing. I recently had an offsite with my team and we were looking for a fun activity to do. And one of the things we did is we said, hey, we talk about these evaluation metrics all of the time, but then do we really understand what they mean? And we actually got the team to answer, we did a Kahoot where we asked the team to answer 20 questions from different evaluation benchmarks like MMLU, GSM-8K, human eval, and people are just blown away by how difficult some of these questions are. So, it's pretty easy for LLMs to do, but then it's actually really hard for us humans to kind of, when you actually realize what questions these evaluations, these benchmarks have, it's actually quite difficult questions. Even the grade school math, which sounds easy, contains some pretty hard math questions. So that was fun, and I recommend everyone to check out these evaluation benchmarks from time to time and see how much challenging they are, not just for LLMs, but also for humans.
By the way, I want to give a shout out as far as the non-open models. I mean, obviously, a lot of people are familiar with GPT-4, but don't sleep on Gemini 1.5 or Claude 3. I mean, I'm increasingly using more of those models. I think we know that GPT-5 is being trained right now. Llama 3 is being trained. So the broader lesson is whatever system you're building, design it so that you can use any of these models, right? So, I mean, that's fair. I mean, because things change so fast. You talk about comparing yourself to Mixtral, but have you compared yourself to Mistral Large?
Yeah, we have compared the DBRX to different frontier closed models. And I would say there is definitely still, right, the closed models are definitely still leading the pack in terms of quality. And it's not very surprising. I mean, a lot of these companies have raised a lot of money. They've been working at it to curate data sets, to build large training infrastructure, to train the models, and their business really depends, right, on these closed models. So definitely, I would say that the models you mentioned, Gemini 1.5, GPT-4, the new large Claude 3 models, they are really good models, and they continue to lead in terms of quality. Although, if I think
But
it's an
also,
interesting question.
I want to also give a shout out to Llama 70 billion. Don't
Yeah.
Llama 270 billion is also a good model that, especially if you can fine tune it, it's quite good.
Yes, exactly. And I was about to say that if you look at the trend, right, of closed models versus open models, and I know there are different levels of openness, but let's just say models where the architecture and the weights are open source and available. The trend is that, in my mind, open models are actually closing the gap pretty quickly. Like if you look, GPT 3.5 was made available, I think, November of 2022, a year and a half ago. No open model came even close to that model. You fast forward to now, you have quite a few of open models that are not as good as the best closed models, but are definitely becoming very close to it, right? And I can argue that you can build useful generative applications with open models today, which you could not before. And I expect this trend to continue, and it could be that the closed models will continue having an edge, but that edge would be gradually diminishing, which I think is fantastic for the community, for the ecosystem, for companies to adopt AI. So it's a very healthy kind of trend.
Yeah, I think you're right, and I think that but that presumes that teams like yours, right? So the team behind DBRX, Llama, they continue to invest and show the commitment. I mean, unless we come up with a true open source model like from UC Berkeley, I mean, given that Berkeley has produced things like Postgres, BSD, Unix, Spark, Ray, and so on, if they can produce an open source model that's out there, that's not controlled by a company, that's committed to getting refreshed. So that's the thing about these things, right, Hagay? So the team that pushes out the model, you're grateful. This is great, but we all know that in 6 months we might need you to push out a new model. So we need that kind of ongoing commitment, right?
Yeah, and I agree it's challenging. And if you look at technologies previously, so yes, the academia played a key role in rolling out really key technologies. I mean, Apache Spark, which Databricks was built on, is a great example for that. And there is, lots of other examples. However, the difference is, in the academia, PhD students, right, they come for free. GPUs do not. And to build great software, you can, use your army of PhD students.
Someone will have to form a kind of a alliance so that they can help contribute some resources to an academic group that is committed to just doing it on an ongoing basis. Because right now we're dependent on commercial companies doing it on an ongoing basis, but their incentives may change over time, right? So.
Correct. And we have to recognize that, commercial companies, corporations, their purpose is to increase the value for shareholders, right? And with that in mind, they have to, serve that interest. I do think that, like I mentioned earlier, the reasons why we built an open source DBRX, there is value. We see value for us as a company in open sourcing because, the community helps build on top of these ideas. They contribute improvements that we can then build on top of. And also it builds our brand. It helps us capture, support more customers, capture more customer workloads. So there is value in that. But it is true that currently it's mostly commercial companies that can fund training these large models. And if we want this to be sustained, we need to make sure the incentives for these companies are lined up. The other, by the way, thing to call out is government investments. I mean, the government played a key role in developing a lot of technology, like space technology and other things that probably would not have, advanced without government investments. And it looks like governments across the world are now kind of waking up to the reality of AI. And I'm hoping, maybe governments can fund some of that, development by, allocating budgets for that. But it's a bit too early to say at this point.
So I would be remiss if I didn't ask you about the license, but for listeners out there, I did read the DBRX license, and it's basically in line with the Llama 2 license, correct, Hagay?
Yeah, so the DBRX license is inspired by the Llama 2 license and, has similar, allowance and similar restrictions. I think that, this license really enables the most important thing for the community, which is helping the AI community develop with new ideas, experiment with new ideas, build on top of DBRX, and really push the entire field forward. And, Llama 2 had a huge impact on the community, and and I'm hoping that DBRX, with the similar terms, would have a similar impact on the community.
So we talked about commitment to improving and innovating and delivering updates to the model. So what's next for DBRX?
So, for DBRX, we're working on some exciting follow-up projects. I think there are a lot of different things we can do. And like the reception software has been really incredible, both in the open community as well as in terms of the Databricks customer base. Within a week, really hundreds of customers starting using it, experimenting with it. And, I think we're going to see really interesting applications coming up. And then there are different paths we can pursue. For example, from building, models fine-tuned for RAG use cases, to multi-turn conversations, to actually building, new interesting models on top of the DBRX base. So, stay tuned for more on that. At this point, I can't share too much. But if I take a step back and look into the entire kind of Gen AI field, I think, we can expect to see bigger and better model coming up, because it doesn't look like we still hit the ceiling in terms of model quality. Like we, can train larger models or on more data or just more data with the same models and figure out new architectural patterns. We are seeing better and better models, and I expect us to see more of that. And then the other thing is, I think everyone's realizing that LLMs are amazing and they really enable us to do new things we just could not do before with software. But when you build an application, you need a system in place. It's not just the model. And we've seen this with RAG. We've seen the rise of vector databases, tools that are made available for LLMs to use. And I think we'll see more of that. And at Databricks, we are also investing a lot in that, because we realize that our customers, to be successful with Gen AI, they need more than just a model. They need a vector database. They need a RAG orchestration framework. They need a good way to evaluate the system.
Pipelines.
Yeah.
Yeah.
So Yeah, so all of that is important, and I expect us to see more and more on the tooling ecosystem that is going to come up and and be broadly used.
Is there any demand from Databricks customers and users around the topic of multimodality?
Yeah, it is. It is definitely coming up. Different business applications, like you can think about customers taking images and then parsing these images. It used to be done with very complicated, customized, ad hoc OCR-based systems. LLMs are able to handle that, much better in many ways. So they both can parse out the text, but also understand the context and relation between objects in an image. So definitely is demand, although I think it's definitely not as strong as the demand for more like text-based processing. But I think as the models become better at that, the more of a strong demand will come up as well.
So the other aspects of Databricks, obviously, the people who listen to this podcast are really aware of are the Lakehouse, right? So I'm assuming that DBRX will help you now write SQL queries, no problem, right? So you don't need a SQL genius anymore to query your Lakehouse. Maybe DBRX can maybe even help you with building some pipelines that feed into your Lakehouse. So what's the is there any near-term interface, Hagay, between DBRX and the folks at Databricks who are working on streaming?
Yeah, so the vision for Databricks that I think we communicated previously as Lakehouse IQ is really, we are infusing the Databricks platform with AI. So it's not just about customers being able to use DBRX or Mixtral or other LLMs with a vector database to build application. It's also when you actually write SQL, so you get an AI assistant that helps you do that. When you are running a Spark in a notebook and you have an error, we have an assistant that actually helps you understand what is the error and how we can overcome it. When you're building your data warehouse, an AI can actually assist you in building it properly, in adding documentation, things like that. Now, some of the things I mentioned actually are already available on the Databricks platform. We have the assistant, we have a really cool feature that actually adds all the description for your tables and your columns for you. And there's a lot of other cool features that are in the works now. You can expect to see more of that. And, one of the reasons we focus DBRX so much on coding capabilities is exactly to boost those capabilities, not just for Databricks, but, also for our broader customers. But obviously, it's really useful for Databricks as a platform. So there's been a bunch of announcements on that, and you can expect to hear more on our Data and AI Summit that is coming up soon.
There's also this in the RAG space, there's the word hybrid is used in two ways. One is just on the retrieval side, right? So BM25 plus plus neural information retrieval. But the more interesting thing and the more customer facing thing that I think Databricks can really play in is this notion of hybrid RAG, where you go, okay, I'll query some text, but I'll also query a data warehouse and produce a better answer. Hybrid analytics and text, right?
Yeah, exactly. And that kind of falls under that bucket of LLMs trained for tool usage, which, like the use case is a query comes into the LLM, and then the LLM may respond with an answer, or it may respond with a request, hey, please activate this set of tools for me. The system takes that output from the LLM, makes the API call, or uses the tools, gets information, and feeds it back into the model, so the model can follow up. And the model may produce the answer then, or actually may ask to use more tools. And you can already see that actually in action in some, chatbots out there that are doing web search or creating code and then running that code in a secured environment to return the results. And in the context of RAG, in general, using tools is going to be very helpful. But in a platform like Databricks, you can envision something like that happening where the system is aware of the tables you have, and the tables it can query, and then to collect information, it actually runs a query against that the data store that you have and uses the output to produce the right output. So that's definitely one of the things that is top of mind for us.
So let's wind down, but I wanted to pick your brain on one topic, right? So on the question of RAG, right? So it was clear early on to people that having some metadata was helpful to the RAG results, which obviously, right? So if you ask a question about, hey, tell me what happened last month, but if you had data sources that had metadata about taking place last month, then better answers.
Yeah.
So, but then now people are speculating, well, if I had an actual knowledge graph, the results will most likely be better, both on the retrieval side and on the generation side, right? So, because the more context I have about the data, the better. So, what's your sense of knowledge graphs in this whole space? Are you personally intrigued, or are you guys working on it, or maybe you're not ready to share, but just broadly speaking, knowledge graphs moving forward, interesting, not interesting?
So it sounds very interesting. In general, it's, if it could be a more efficient or effective way to provide the model with relevant context so it can provide better answers.
And explainable answers. Right?
And explainability, exactly. And you can actually refer back to the source of the information, allow someone to traverse that knowledge graph. So it sounds very interesting and very relevant, and it sounds very useful. Now, I would say that personally, I have not came across a customer that actually uses that at the moment, but it could be that just my perspective is a bit, is a bit narrow, or is not aware of it, but it does look like something that can be very useful.
So one of the challenges, Hagay, in this area is it's conceptually interesting, but I don't have a knowledge graph. So either I construct it by hand, or I use one of these automatic tools, which sometimes works, sometimes does not. And it seems like the place where it pops up a lot is in text to SQL, because there are tools where if you have a relational schema, you can get to a knowledge graph, and so then people are able to take their database, create a knowledge graph, and then use that to help the text to SQL system.
Yeah, again, it sounds useful. I think, again, there is a little bit of the chicken and the egg in these situations, right? Because if the systems are not available, then people would use them less and less experiment with them, etc. I think one of the powerful things about VectorDB and similarity search is that the tooling has been available previously, because VectorDBs have been used for things like recommendations and search previously. So it was just kind of ready at the right time for LLMs to use, and that was kind of a very lucky coincidence that enabled the rise of VectorDBs. But I think, to your point, VectorDBs are not always actually the best mechanism for retrieval. It's just very convenient to use them. And what you mentioned, we are also learning that actually BM25 sometimes is a better solution than vector similarity search. And I would say definitely the combination of BM25 with vector similarity search, the hybrid one, that's like a winner thing easily in most use cases. So going back to knowledge graphs, the tooling first needs to be available for really people to experiment with it and figure out how useful it is. In theory, it sounds super interesting because of the properties you mentioned. You can actually, go back to the graph, you can traverse it, and etc.
It has to get to the point where a regular developer who's not a knowledge graph nerd can just use it, and then, I mean, a lot of the things we talk about are highly empirical, right? So, like, honestly, the reason I like Llama 70 billion is I get good results, right? So nothing more than that, right? So I cannot explain why, but I maybe I'm good at prompting Llama 70 billion. So same thing with a lot of the things we talk about. People need to be able to try it. If you you can talk their ear off, but if they are not able to try it, then that won't move the needle in terms of popularity. And in closing, one last thing. So let me see if I can get you to agree with me on this. I don't know if these vector databases are standalone companies, though. Okay, I mean, I think that a lot of the capability will be integrated into existing systems, and existing systems are already in place in a lot of companies. You have to provide so much additional value for me to bring in another vendor just for vector search, right? So agree or disagree?
I agree that it's a big challenge for the vector DB companies. On what there are, and by the way, this we can see this in other similar systems where that challenge is. But the opportunity for these companies is that there is a massive increase in the workloads because there's more the traditional search and recommendations. By itself, it's fairly large actually workloads. But then generative AI just kind of exploded. And to leverage generative AI with LLMs today, you really need a RAG system, which requires some kind of vector database that you can
Or vector search, which is now available in Postgres, MongoDB, right? So
yeah, exactly.
Cassandra.
So the opportunity is there. The challenge, of course, like you mentioned, is that it's becoming a feature of more traditional stores that most companies have. Plus, the large providers can offer that as an add-on, and customers' data is already there. So when they want to embed it and index it, if I'm a developer, it's much easier for me to just spin up, write a capability on my existing cloud providers and use it. So that is the challenge for these companies. I think you can look at other companies who've been doing fairly well, I'd say, in similar challenging situations. Like you look at Elastic, you look at,
Elastic is adding it, right? So
but Elastic, in terms of just search in general, right? Like there's a similar challenge for them. So, and all the cloud vendors, or most of them today, offer similar capabilities to Elastic, but Elastic is still able to differentiate itself, and because they're focused on that problem space. So the opportunity definitely is a challenge, and I agree with you that I think these companies have to find ways to differentiate themselves and offer value add that goes beyond kind of the basic capability of, hey, upsert, right, an item, and then do a search. They can potentially expand into actually offering optimized embedding models, and offering kind of more of a built-in end-to-end solution, maybe even offering RAG on top of the platform. But it's definitely I think a big challenge for these companies, and it's not necessarily trivial to see how they are, be able to handle that challenge successfully, at least for many of them, at least.
So in closing, and I will put links in the episode notes. So how can people get involved with DBRX? Are there meetups? Is there a Discord channel? So
DBRX architecture is on GitHub, Databricks /DBRX. It was trained with open source tools, so Composer, which is a distributed training library, LLM Foundry, which is all the recipes, streaming data set, which is, I stream the data in, and it's all on GitHub, and people can check it out over there. There's also a space on Hugging Face where people can experiment with the model. The model card is there, so people can engage on that. And there are a couple of meetups we are setting up, and we are very, the team who built DBRX is very much kind of open source, focused. So if you put in issues there and, raise things on Hugging Face, we will respond. And we'd especially love to hear, how DBRX is used for different projects, either commercial or non-commercial, doesn't matter. And we would love to hear from everyone who is using it.
And obviously, Data Plus AI Summit is a great place to meet the team.
100%. Yes, we will be there for sure.
And with that, thank you, Hagay.
Thank you, Ben.